Hello students, in this video you are going to learn about selection of circuit breakers. So what basis we are selecting circuit breakers, that you will learn in this video. Before that we will see what is meant by circuit breaker, what is the difference between fuse and circuit breaker. So circuit breaker is a device, automatic device, so which is used to isolate the fault from the abnormal conditions, and also it is used to protect the devices from the abnormal conditions. So abnormal conditions like over current and over voltages. So compared to fuse is the oldest device and simplest device. So once fault current comes, once heavy current flows to the circuit more than the rated current, the fuse element will get heat and it will melt, so it will isolate the fault. So similarly, the fuse will give the fire hazards, but circuit breaker will not give the fire hazard. Whenever abnormal conditions comes, automatically moving contact moves away from the fixed contact, so it will open, so isolate the fault. But fuse once melt, so we need to replace manually when with any one element. But circuit breaker is not like that. When fuse circuit breaker will get melt, circuit breaker will also opens the contact, so easily we can close that contact. So now we will see the circuit breaker, how it will be and what basis you are going to select the circuit breaker. So when the fault occurs in a part of the power system, heavy current flows. Fault means either short circuit fault or unsymmetrical fault, symmetrical or unsymmetrical fault occurs. So heavy current flows due to short circuits. Fault heavy current flows in a part of the circuit, so which may cause permanent damage to the equipment. Permanent damage to the equipment. Hence, the fault part should be isolated from the healthy part immediately on the occurrence of a fault. So when they isolate the fault, so immediately we need to isolate. Otherwise, if you are not isolate by the time, so if you wait, if you do slowly isolate the fault, so if you open the contacts way, it will take, if you take time, so by the time your appliances will get damaged. So here, so immediately we need to separate, we need to isolate the healthy part. Okay, so this can be achieved by providing protective relays and circuit breakers. So relay is like our mind. So relay will sense the fault and it will give supply to the circuit breaker, right? So the protective relay sense these fault conditions and sends signal to circuit breaker to open the circuit under faulty conditions. The circuit breaker can be used as a switch. Circuit breaker used as a switch. So once if you switch off, so circuit will be open. When switch on, circuit will be closed. So that machine or that equipment will be operate. Like that, circuit breaker will also will acts. So it will have two contacts, moving contact and fixed contact. So when a fault occurs, so these two contacts will separate. So the selection of circuit breakers for a power system depends not only upon the current that breaker it to carry under normal operating condition, but is also upon the maximum current. So normal current is not a matter, but operating current should be maximum. So it may have to carry momentarily and the current is may have to interrupt at the voltage of the line. So in which it is placed. Hence, the choice of circuit breaker for particular appliances depends on the following rating of the circuit breaker. So choice of circuit breaker, so particular application. So if you are using for power generation, if you are using for your home, circuit breaker rating, circuit breaker capacity is different. So we need to choose the circuit breaker based on the application. So application, suppose if you are using homes, circuit breaker size should be very less and rating should be very less. Suppose if you are using for power transmission with substation, so if you want to use this circuit breaker in substation, so there will be heavy voltages, so heavy currents, so we need to choose the high rating circuit breakers. So now we will have some different points to select the circuit breaker. The first point, normal working power level specified as a rated interrupting current or rated interrupting MVA. So normal working power level specified as rated interrupting current or rated interrupting MVA. So based on the interrupting current and based on the MVA rating, we need to select. The fault specified as either the rated short circuit interrupting current or rated short circuit interrupting MVA. So the fault current specified either as either the rated short circuit interrupting current or rated short circuit interrupting MVA. And momentary current rating. So momentary current rating, normal working voltage, the speed of circuit breaker. So we need, suppose if you are using high voltage applications and extra high voltage application, the speed of circuit breaker should be more, time taken for operating should be less, and speed should be more. For using low voltage circuits like home appliances and power distribution side, secondary distribution side, and even for agriculture motors. So the rating of circuit breaker is less, but the operating speed also should be more. So those things we have to choose: speed of circuit breaker, normal working voltage, normal momentary current rating. So these are the methods, these are the points while we are choosing the circuit breaker. The speed of circuit breaker is the time between the occurrence of the fault to extension of the arc. So time, the speed means how will based on the time. So if it is less time, the speed is more. If it is more time, the speed is less. So based on the occurrence of the fault to the extension of the extinction of the arc. So open the contacts. So contact should be open. So it is normally specified in the cycle of power frequency. So one cycle for 50 Hz power frequency is 1 by 50, that is equal to 0.02 milliseconds. The standard speed of circuit breaker are 8, 5, 3, 2 or 1 or 1.5 cycles. The speed we are measuring in terms of meter per seconds, or so the time we are measuring in terms of milliseconds. So now we will see the ratings. So multiplication factor of circuit breaker. Circuit breaker will open the contact usually in the transient period, and so that short circuit interrupting current ratings depends on the transient currents. So usually operates on transient periods and transient currents will be operate. Okay, so the factors are the factors here we have varies from 1.0 to 1.5 accounts for the DC offset current during the transient period. So for factor is 1.0 to 1.5 varies transient period. The circuit breaker is chosen so that it is short circuit interrupting current rating is less than the calculated value. So short circuiting interrupting current rating is less than calculated value. So while you are choosing the circuit breaker, we need to take care of interrupting current rating is less than the calculated value. The multiplying factor to find the interrupting current depends on the speed of the circuit breaker. There are indicating in the table. The 8 cycles are more, the multiplying factor is 1. 5 cycles are more, 5 cycles are 1.1, and one and a half cycles. Suppose 1.5 cycle means multiplying factor is 1.5. The multiplying factor find the interrupting current depends on speed of the circuit breaker. So interrupting current depends on speed of the circuit breaker. So by that here we have a table, speed of the circuit breaker versus multiplication factor. The speed is the time taken is more, the multiplication factor is less. Time taken for the speed of circuit breaker is less, multiplication factor is increased 1.5 for 1.5 cycles. Okay, so this is about selection of circuit breakers. So in next video we will see about problems on reactance and impedance diagram. So it is belongs to module 2. So these problems are very important for your examinations. So we will see in next video problems. Okay, thank you everyone.